In this section, we're going to take a look at a little bit of graphing. Now, I'm quite convinced you've all done some graphing before. I've put a grid here on the screen. And I want you to notice a couple important things about my grid. First off, my axes are both scaled. And what I mean by scaled is you can see along the x-axis, I've got 2, 4, 6, 8 marked, -2, -4, -6, -8. And then on the y-axis, I don't mark quite as much, only 0, 5, and 10. There's no real set rule on scaling, how much scaling you have to give, other than you have to give it. Okay? If you don't give scaling, then the graph really is pretty meaningless. So if you give me a graph and your graph doesn't have scaling on it, I'm certainly going to mark it wrong right away. Now, I'm, like I said, convinced that you've all seen graphing before, so I'm sure you're familiar with marking points on the graph, such as that. That would be the point 2, 5. The left and right always comes first, so that one went 2 to the right and 5 up. Let's see, here's another point. How about that one right there? That one would be 3 to the left from the origin, so that one would be -3, 2 down, -2. Okay, I'm sure you're familiar with graphing points. Now, we're not going to graph points so much in this section as we are going to graph equations. Alright, so you're going to be asked to graph equations by finding intercepts. So you might be asked, graph y equals 2x minus 4 using intercepts. Well, intercepts are the spots where the graph crosses the x and the y-axis. In my opinion, the easiest way to find intercepts is to just build yourself a little table. When the graph is going to cross the y-axis, x is going to be 0. So I take my equation, I plug 0 in for x. When I plug 0 in for x, that one's pretty easy to figure out. I get y equals -4. So here's 0, -4. And that's called the y-intercept. It's a little hard to draw intercepts on here. A little hard to draw nice dots. Alright, and then we have to find the x-intercept. To find the x-intercept, we switch it. We simply plug 0 in for y. If I plug 0 in for y, I end up with a little equation. 0 equals 2x minus 4. And I'm going to skip the steps here. I'm sure you can solve that equation in your head, pretty much. You get x equals 2. So I get 2, 0, that's right there. And then I would connect the dots. Draw my graph. Now, of course, there are other ways to graph that equation, and again, we're going to be talking about that. I'm guessing most of you, if you were to graph that equation, you would go ahead and you would use the slope and the intercept. That'd be great. But an equation like this, I don't like that y very much, isn't so easy to graph using the slope and the intercept. In order to use the slope and the intercept, you got to do a couple of steps. You got to get y all by itself. Personally, I think it's an awful lot easier to graph an equation like this by finding the intercepts. I plug 0 in for x. If I plug 0 in for x, I get -5y equals 15. Divide both sides by -5, y equals -3. Conversely, if I want to find the y-intercept, the x-intercept, I plug 0 in for y. When I plug 0 in for y, I get 3x equals 15. Divide, x is 5. Alright, so I have 0, -3. That's right there. I have 5, 0. That's over there. I draw a nice straight line. Now notice, these first two graphs that I drew, these first two graphs were lines. Why are they lines? They're lines because these equations are linear. And again, what I mean by linear is I have an x. I don't have any powers on my x. No squares, no square roots, no cubes, no fractions with x's in it. Same with the y. No powers, no anything on it. So these are both linear equations. What if I gave you a nonlinear equation? What if I asked you to graph y equals x squared minus 3? Now again, I'm going to guess that you've probably seen graphing before. You've probably graphed equations that look like this before. Probably not a big deal. So there are lots of things you might know about this. But the most basic thing we do when we don't know what a graph looks like is, again, we build ourselves a little table. And we plug our favorite numbers in for x. And my general rule of thumb is I like to plug in a couple negative numbers. I like to plug in 0. And I like to plug in a couple positive numbers. So I would plug in things that look like that. Plug in negative 2. Negative 2 squared is 4. 4 minus 3 is 1. Plug in negative 1. Negative 1 times negative 1 is 1. 1 minus 3 is negative 2. 0, I love to plug 0 in. It's always easy. I get negative 3 in this case. Plug 1 in. I get 1 minus 3. That's negative 2. And plug in 2. I get 4 minus 3. That's 1. Alright, so I draw my points here. Negative 2, 1. Negative 1, negative 2. 0, negative 3. 1, negative 2. 2, 1. Oops. Didn't mean to do that. 2, 1. And I connect the dots with a nice smooth curve. Missed a little bit, but you get the idea. This graph is known as a parabola. So notice this one is not linear. It's certainly not linear because it has an x squared. Anytime you have an x squared, you're certainly not going to get a linear equation. And your graph isn't going to be a line. Alright, so you're going to have some graphing like that to do by hand. You're also going to be asked to graph some things in your graphing calculator. What I recommend for the graphing calculator is you look on the course. There's a whole section on graphing calculator, and there are some videos in there on how to graph using your graphing calculator. So go ahead and take a look at those. Alright, the next thing we have in this section are a couple formulas. We have the distance formula. Very nice looking R there. Distance formula. Alright, so let's say we have a couple points. Let's say we have the point 3, 4. And we have the point negative 2, 1. And what we want to do is we want to connect those two dots with a nice straight line segment. And what we want to know is we want to know how long that line segment is. Well, there's a formula for doing that. And I'm not just going to give you the formula, I'm going to show you where the formula comes from. Where the formula comes from is you complete the right triangle. And with the right triangle, I'm sure you know the Pythagorean theorem. So let's see, this point right here, this would be the point 3, 1. So if I call this side A and this side B, then this side would be C. So we would have C squared equals A squared plus B squared. But what we're really trying to find is really just trying to find C. So to find C, I take the square root of both sides. C is the square root of A squared plus B squared. Alright, now how long is A? Well, A, we start here at negative 2, and we end here at 3. That's a distance of 5. And notice the way we can get that distance is by subtracting the x coordinates. So I have 3 minus negative 2. That gives me 5, and that's the distance of A. So notice that A is x2 minus x1. So we subtract the x numbers to find the A distance. Similarly, we can find the B distance by subtracting the y numbers. So B is 4, that's our highest point, minus 1, that's our lowest point, that's 3. So to find B, we subtract the y values, y2 minus y1. Alright, so here's our distance formula. Usually we don't use c, usually we use d for distance. And the distance formula is the square root of, subtract the x numbers, x2 minus x1 squared, plus subtract the y numbers, y2 minus y1 squared. So that's known as the distance formula. Alright, so in this case, x2 minus x1, we already figured that out. That's our a number. That was 5, so that would be 5 squared. Plus y2 minus y1, we figured out y2 minus y1, that's b, 4 minus 1, that's 3, 3 squared. And then we square root the whole thing. So we end up with square root of 25 plus 9, that's 34. Alright, so there's the distance formula. The distance formula, you subtract the x's and square them, you subtract the y's and square them, you add those two answers together, and then you square root the whole thing. The other formula in this section is known as the midpoint formula. Let's say we had, let's see if I can remember what 2 points we had. I think we had 4, 3. Doesn't really matter what points we have. And then negative 2, 1. And again, we connect those with a line segment. An important point is the point right in the middle. Alright, to figure out the point right in the middle, not too difficult. It's called the midpoint. What you do, it's a point, just going to have a parenthesis like this. The midpoint is halfway between the x's. So you add the x's together and divide by 2. And then it's halfway between the y's, so you add the y's together and you divide by 2. So in this case, the midpoint is going to be 4 plus negative 2, that's 4 minus 2 over 2, comma, at the y's, 3 plus 1 over 2. Alright, so that's 1, comma, 2. Doesn't look right in my picture. Did I do something wrong? Oh, I did something wrong in my picture, didn't I? I told you I was going to give you the point negative 2, 1, but then I drew the point negative 1, 1. That's why it doesn't look right in my picture. Let me fix my picture here. Alright, so here's 4, 3, negative 2, 1. Connect those. And then halfway in between, looks like it's right about there. So my graph isn't completely accurate still, but it looks closer now. It does at least look like the point 1, 2. Alright, well, the reason we talk about the midpoint formula and we talk about the distance formula is to talk about the last thing in this section, and that's circles. A circle comes from an equation that looks like this. X minus h squared plus y minus k squared equals r squared. And if you think about that for a minute, that looks an awful lot like the distance formula. R squared, think of r as being the distance, so you got distance squared. Over here you have x minus something, so it's kind of like x2 minus x1, kind of subtracting x numbers there. Same with the y's. It kind of looks like y2 minus y1, and it really is. Because h and k are special things. The point h comma k is the center. R is the radius. So, let's say for example I were to give you x minus 1 squared plus y plus 3 squared equals 4. Well, what you would know right away, your center is h and k. Now notice these formulas have minuses built in. So our center here, this one already has the minus, x minus 1, so this one would be a 1. This one doesn't have the minus, we'd have to write it as y minus negative 3. So that would be negative 3. So there's our center, and our radius is 2, because 2 squared is 4. Alright, so here's what you kind of do. you mark your center. Your center is 1, -3. It's right there. Now that center is not part of the graph. To find the graph, you mark 4 points. And the way you mark 4 points is you start at your center and you go to the right 2. So there's 1 point. You start at your center, you go up 2. Start at your center, go left 2. And finally start at your center and go down 2. That gives you 4 points. And you connect with something that is supposed to look like a circle. Alright, now let's see what the midpoint formula and the distance formula have to do with a circle. I'm going to clear off the can. I think I need to go in a minute. So I might tell you, I'm going to give you 2 points. I'm going to give you 3, 5 and 1, -9. And those 2 points lie on the diameter of a circle. So what I mean is I have a circle here, and I've got 1 point that's 3, 5. So 3, 5 might be right here. And then I've got another point here, which is 1, -9. And that forms the diameter of my circle. Not drawn to scale, doesn't really matter, it doesn't really need to be drawn to scale. What we need to know is we need to know the midpoint, because the midpoint will give us the center of the circle, and we need to know the radius. Well, the radius is half of the distance. So here's where the distance formula and the midpoint formula come in with circles. So to find the center, I find the midpoint. So to find the midpoint, again, I add my x's. So I have 3 plus 1, and then I divide them by 2. And then I add my y's. 5 minus 9 divided by 2. So that's 4 over 2, that's 2. That's -4 over 2, that's -2. So there would be the center of my circle. 2, -2. And then I need to find the radius. To find the radius, I find the distance between my 2 points. So to find my distance, I have the square root of, I subtract my x numbers, 3 minus 1, and then I got to square it, plus, I subtract my y numbers, 5 minus -9, that's 5 plus 9, squared. So that's the square root of 3 minus 1 is 2, 2 squared is 4, plus 9 plus 5 is 14, and 14 squared happens to be 196, so we end up with the square root of 200. So that's the distance between those 2 points, so the radius would be half that. So the radius would be square root of 200 over 2. That radical could be simplified. I could simplify that fraction, but I'm just going to leave it like that just for now. I need some more room. Let's see. So erase this here. So, my equation now, my equation of that circle that I just erased would be x minus h squared plus y minus k squared equals r squared. So short on room there, but you'll see it. Alright, so I have x minus h. H is 2. X minus 2 squared plus k is -2, so I'm going to have y minus -2. That's y plus 2 squared equals square root of 200 over 2, whole thing squared. Alright, so now I would do a little simplifying. I would write my final answer as x minus 2 squared plus y plus 2 squared equals, the square root of 200 squared is just 200. A square and a square root cancel each other out, so that's going to be 200 over 4, because 2 squared is 4. So, final answer, x minus 2 squared plus y plus 2 squared, it doesn't look like squared, equals 50. Alright, so there's where our distance formula and our midpoint formula come in. They are used in conjunction with circles a lot.